Hey guys, it's Miss Johnson here, and I'm here to bring you our last and final notes video for Algebra 2B. We're talking today about section 9.6, which is on exponential growth and decay. So up at the top, our first example says certain assets like homes can appreciate or increase in value over time. Others like cars depreciate or decrease in value with time. The first example says, suppose you buy a car for $22,000 and the value of the car decreases 16% each year. Write an exponential function in the form of y equals a times b to the x. Um, that could be used, this form right here, that could be used to model the price of that car. Write the function in terms of x, the number of years since you purchased the car. So if I were going to write a function for this, I first need to figure out what percentage I'm using as my decay rate, because this is going down, decreases. Now, I know that my decay rate is 16%, which means that I started with 100%. I'm subtracting 16% each year. So each year, in an essence, I'm keeping 84%. So I'm keeping 84%. That's what I'm going to use for my B. B is going to be 0.84. So if I write a model for this, that means I have y is equal to 22,000 times 0.84 all raised to the x power. And then it says find the value of the car 2 years later, 3 years later, and 7 years later. So three different answers here. First one, y equals 22,000 times 0.84 to the second power, which when you type that into your calculator, you end up with about $15,523. 23 and 20 cents. 7 years or 3 years later would be if I plugged in a 3, so y is equal to 22,000 times 0.84 to the third power, which is about $13,039.50. And 7 years later, y is equal to 22,000, my starting dollar amount, 0.84 raised to the seventh power, which gives me about $6,491.99. So that's what I would get if I plugged those three different years in. So this is an exponential decay question. Exponential decay is when a quantity decreases by a fixed percent each year over a period of time. So I take that 1, like we talked about, we had 100%, which is 1 as a decimal, and subtract that decay rate. Whatever your decay rate is, you got to take that away. Okay. So then it says where A is the initial amount, R is the percent of decrease, and we're writing our percents as decimals here. Make sure you pay attention to that one. So let's take a look at this next example. It says a cup of coffee contains 130 milligrams of caffeine. If caffeine is eliminated from the body at a rate of 11% per hour, how long will it take for half this caffeine to be eliminated? So here's the thing. I know this is my decay rate. And I know that this is my starting amount. That's my A. Here's my R. I'm trying to find the T. The other thing that I have to consider is what does that half mean? Half would be as about, um, 0.5 of whatever the starting value is. And that is going to be the y. That's the end result. So this is kind of like one of those where I'm missing something within the formula. I'm not looking for the end result. Here I have the end result. So I have to think about what half of my a value is. This a value was 130. That means that 0.5 or half of the 130 is 65. So I want to be down to 65 milligrams. I started with 130. I had 100% and I'm subtracting 11% each hour, right? Yeah, hours we're looking at. And I'm trying to find the t. Okay, so now I need to solve for that missing exponent there. I'm going to start by taking the 65. I'm going to fix that rate, 130. 1 minus 0.11 is 0.89 to the t power. And then I'm going to divide by the 130, which we all know what that's going to be because we just found it. We have 0.5 equals 0.89 to the t power. Now I want that t to come out front. Since I want that t to come out front, I need to use logarithms. So I'm going to have the log of, I'm going to take common logs, use the log of each side. Log of 0.5 is equal to the log of 0.89 to the t power. And then we all know that that makes that t come out front because that's our property of logs there. So I have the log of 0.5 is equal to t times the log of 0.89. Now I can find t by dividing by the log of 0.89 divided by the log of 0.89. So that's what you need to type into your calculator now. I have t is equal to the log of 0.5 divided by the log of 0.89, which when we plug that in is about 5.9. So if I'm rounding this and I think of it in terms of hours, I would say it takes about 6 hours. So we started with an exponential decay question. We were trying to find the missing exponent. Now that we know our properties of logs, we can use the logarithms to solve for that missing exponent. Let's take a look at number 2. In number 2, it says a store is offering a clearance sale on a certain type of digital camera. The original price of the camera is $198. If the price decreases 10% each week until all of the customers are sold, or I'm sorry, all of the cameras are sold, how many weeks will it take for the price of the cameras to drop below half? Below half of the original price. So, again, I know that I'm starting at 198 bucks, and I know I want to get to half of that. So 0.5 times 198 is $99. So I want to be below $99. So I'm going to set this up. My final amount is $99. My initial amount is $198. I'm starting with 100% and I'm subtracting 10%, which is 0.1, and I'm trying to figure out how long that will take me. I don't know the time. So simplify that. 99 is equal to 198 times 0.9 to the t power. Divide by 198, divide by 198, and we all know because we just found that, that is going to be a half. So I have 0.5 is equal to 0.9 to the t power. Now I use logarithms of both sides. The log of 0.5 is equal to the log of 0.9 to the t power, which pulls that t out front based on the properties of logs we learned in 9.3. So t times the log of 0.9 and divide by the log of 0.9. So, log of 0.9. So this guy right here is what you need to plug into your calculator. The log of 0.5 divided by the log of 0.9, and I end up with t is approximately 6.57 weeks. Now, that's how long it's going to take for us to get to half. We wanted to know how long it would take to get to below half, so I need to go a little bit beyond that because that's going to take me below the halfway mark. If I stop at the 6, I'm not quite to the halfway mark. I need to go beyond that. So I would say in this case it's about 7 weeks. And there we have it. Let's take a look at exponential growth, and then we'll move on from there. So in exponential growth, it says now a quantity is increasing by a fixed percent each year, or another period of time, and the amount y of that quantity is given by t is the time, a is the initial amount, r is the percent, and notice in this formula now we are adding the growth rate. So for decay, we were subtracting the decay rate. Now we're adding the growth rate in growth, which makes sense. So if I look at number 3, it says in 1910, the population of the city was $120,000. Since then, the population has increased 1.5% each year. The population continues to grow at this rate. What will be the population in 2010? So now I know the time because I know that 2010 minus 1910 is 100. So that is my t. I know the starting amount, that's my A. I know the growth rate, that's my R. And I'm trying to find Y. So I can set this up. Y is equal to starting amount, which is 120,000, times the growth rate, 1 plus 0.015, because that is 1.5% as a decimal, raised to the 100th power. Plugging that all into your calculator, you end up getting y is equal to 531,845. and we're talking about people here. So there's my growth rate question. All right, we're going to go ahead and stop our video at this point. Thanks for listening. Don't forget to hop back to Schoology and take your Schoology quiz. Thanks for listening. Have a great night.